My name is Neha Sinha, and this is Lab 7 on finding the mass of a black hole. The main problem addressed in this lab is how to determine the mass of a black hole based on observations of a star moving around and interacting with it. The chief results of this lab will be finding the black hole mass by applying fundamental laws such as the momentum principle and gravitational force, and using data gathered from observing the star. In VPython, to model the star and the black hole, we created shapes for figures and arrows to represent the forces. These are the initial conditions and steps for finding the black hole mass. The mass of the star is 1.989 times 10 to the 30th kilograms. The given time step is 1 day, measured in seconds at 86,400 seconds. A while loop was written to run through the time steps and compute the x and y components of the velocity of the star. These calculations were then used to find initial and final velocity and momentum, which were, in turn, used to find delta v and delta p, or change in velocity and change in momentum. The momentum principle was then applied in the following manner. Here's the momentum principle. Divide each side by delta t. And here, it is clear that the derivative of momentum with respect to time is, by the momentum principle, equal to net force. And their parallel and perpendicular components are also equal. Then, in VPython, arrows were adjusted to represent net force and its parallel and perpendicular components. Finally, to find the mass of the black hole, the given position was inputted. Using the formula for gravitational force, it was possible to adjust the equation to solve for black hole mass. All quantities on the right side of the equation are known. Python calculates the black hole mass to be about 2.179 times 10 to the 31st kilograms. Here's the model. The black arrow is dp/dt, or net force. The blue arrow is the parallel component, and the red arrow is the perpendicular component. What does it mean? Well, I've already shown that net force and change in momentum over change in time are equal by the momentum principle. In the same manner, their parallel and perpendicular components are equal. However, though their values are the same, as conceptual quantities they are different. Knowing the net force can allow momentum to be calculated. But momentum, unlike force, can be observed and calculated and used to assume the force acting on the object to cause that momentum. To simplify, it can be said that a change in momentum with respect to time is caused by a net force. The what-if question asks if in observations it would be noticeable if the black hole is replaced by an entirely different black hole at the same location, which does not change the motion of the observed star. The answer is that it's not possible to tell the difference because every element of the black hole we calculated or determined was based on the star circling it. If the star does not change motion and does not appear to change in any other way, we can assume that the black hole has not changed. So, we have achieved our objective in determining the mass of the black hole. Thank you for watching.